Imagine you hire the smartest genius in the world. They know every coding language, every algorithm, and every historical fact up to last year. But then you ask them a simple question: how's the weather today? And the genius freezes. They panic. They might even make up a fake answer just to please you. Why? Because intelligence is not the same as knowledge. They have the intelligence to solve complex problems, but they lack the context of your specific life. This is the fundamental problem with AI models today. They're answering from memory, a closed book exam. But don't worry, we can fix this. Let's build an architecture that gives the AI a textbook. This is called RAG, Retrieval Augmented Generation. By the end of this video, you won't just understand the theory, you will have a Python script running locally on your machine that turns a standard AI model into an expert on your private data. Let's break down RAG using a pure analogy. Think of the large language model, LLM, as a student taking a final exam. Think of your private data, your PDFs, notes, and emails, as a massive library. In a standard interaction, the student sits in an empty room. If you ask a question about a book they've never read, they have to guess. This is where hallucinations come from. RAG changes the rules. It turns the test into an open book exam. Here is the three-step process. First is retrieval, the librarian. When you ask a question, the student doesn't answer immediately. First, they run to the library and find the one specific page that contains the answer. Second is augmentation, the cheat sheet. They photocopy that page and staple it to your question. And third is generation, the essay. Now they write the answer using only the facts on that stapled page. The student didn't memorize the library, they just learned how to look things up. Let's turn this story into actual Python code. We are using 3 open-source tools to build our student and library locally. First, the setup. We need a student, the AI model. We're using Llama 3.2, running via Ollama. We need a library, the database. We are using ChromaDB. And to convert the text into embeddings, the translator, we are using nomic-embed-text. Before we write a single line of Python, we need to hire our student. We do this using Ollama. In your terminal, you'll run Ollama pull Llama 3.2. This pulls the brain of the operation onto your hard drive. Next, we need our indexing system, so run Ollama pull nomic-embed-text. Now, let's look at the Python blueprint. First of all, import libraries. Now let's look at the local RAG class. The init method is where we construct the building. We define our student, Llama 3.2, and our translator, nomic-embed-text. Then we initialize ChromaDB. Think of ChromaDB as the physical bookshelves where our data will live. Next, we have the add documents function. This is the librarian organizing the books. Computers don't read English, they read math. We aren't just saving or putting text on shelves, we are converting the text into embeddings using nomic-embed-text. We are using the Ollama.embeddings function to turn every sentence into a vector, a long list of numbers. Think of an embedding as the Dewey Decimal System for concepts. It turns sentences into lists of numbers so the computer knows that apple is closer to fruit than to iPhone. We store these number maps in ChromaDB collection. Now the user asks a question: who is the project lead? Here is the retrieval step in code. Inside the query method, the first thing we do is retrieval. Notice what happens here. We don't send the question to the AI yet. First, the librarian turns your question into numbers, question embedding. Then collection.query scans our library or the shelves to find the one most relevant paragraph. It grabs the specific page from the book and stores it in retrieved context. This next part is the secret sauce. This is augmentation. We take that page we found and we literally paste it into the prompt. Do you see what we did? We changed the exam question. Originally, the question was just, who is the project lead? Now the prompt is a set of instructions. Here is a document that says Sarah is the lead. Now, using only that, answer who is the project lead. We have made the exam impossibly easy for the student to pass. Finally, generation. We send this cheated or stapled prompt to our Llama model using Ollama.chat. The model reads the context we gave it and simply rephrases it into a human-friendly answer. It didn't hallucinate, it didn't guess, it just read the note we handed it. Let's watch it run. In the final block of our code, we put it all together. We define a knowledge base with specific facts about Project Phoenix and Sarah. We call rag.addDocuments to stock our library, meaning load data into the vector DB. And finally, we run our queries. When we ask who is leading the back-end team, the code retrieves the Sarah document, staples it to the prompt, and gives you the perfect answer. Similarly, for the second question, we get the correct answer 500 requests per minute. And look at the France test. Since our library doesn't have a book on European geography, the code is instructed to say, I don't know. This is how you kill AI hallucinations for good. Finally, I've added a fake fact to our knowledge base. To reset the server, hold the red button for 5 seconds. If I ask a standard AI this question, it would guess generic advice like restart the service. But watch our RAG agent. It retrieved the specific rule we created and generated the correct answer. Celebration time. The student aced the open book exam.
Congratulations on your outstanding achievement. Well done.
This architecture is the backbone of modern AI applications. Whether you're building a legal assistant, a medical bot, or just a personal file organizer, a logic is always the same. Retrieve the right page, augment the prompt, generate the answer. Now you can apply this RAG technique with your favorite LLMs. Give your AI a library and stop the hallucinations.